Today we're going to look at the factored form of a quadratic equation. So the last couple classes we have reviewed how to factor quadratic equations, and we're going to use that to help us figure out the answer, or rather to sketch the graphs of quadratic functions. So example, sketch the graph of the quadratic function x squared plus 4x minus 12, and then state the domain and range. So there's two pieces to this question. There is the graphing part and the domain and range part. So the first thing that we need to do is we need to zero in on the quadratic piece of the function. We need to take a look at x squared plus 4x minus 12, and we need to factor this, all right? We need to factor this. So how do we factor that? Well, we just take a look at it as x squared plus 4x minus 12 equals 0. Or actually, we don't even need to do the equal 0 part. We can just do it like that. And we're looking for two numbers that multiply to negative 12 and add to, correct, add to 4. So what are those two numbers? They are negative 2 and 6. So I'm going to write that as x negative 2 or x minus 2, and then x plus 6. And again, I can have the x plus 6 come first if I want to. The order does not matter of the two brackets themselves. So now, how does this help us? How does this help us? Well, here's the thing. What I can do is I can ask myself, what values make each of the two brackets equal to 0. So if I take a look at the first one, what value of x makes that equal to 0? What's that? 2? So x equals 2 from the first one. And what value of x makes the other one equal to 0? Negative 6. So x equals 2 or negative 6. So how does that help us graph this? Well, here's how it helps us graph it. First off, now I know for sure I can figure out the horizontal part of my scale. I know that I can label my x-intercepts because that's what these are, is they're my x-intercepts. So this is going to be 2 right here, and this is going to be negative 6 right there. Now, I don't know much else quite yet, but I know that those are my x-intercepts of my quadratic function. Now, here's what else I know. I know that quadratic functions are symmetric. That is, the vertex will be halfway between these 2 points. So I don't know where it's going to be, but I know that if I drew in an axis of symmetry here, I know that it's going to be halfway between these 2 points. What x value is halfway between those 2 points? Negative 2, right here. Because if it's right here, it's 4 on either side. So I know that the vertex is going to be somewhere along that line of symmetry. Here's what else I can try and figure out. From the first couple days we talked about quadratic functions. I've got a question for you. Is this quadratic going to point up or point down? Why? Because the coefficient on the x squared is positive, right? It's just 1x squared, and if that number in front of x squared is positive, it is going to point up. So I don't know where it's going to live, but I do know that the vertex is going to come somewhere in the bottom half of this graph. Now the question is, where is it going to be? Well, here's what we can do. We know that the x-coordinate of the vertex is a -2. So what I can do is I can plug in x equals -2 into either this form or this form of that quadratic equation. So I'll put it into the bottom one, and it does, honestly, it doesn't matter. So I'll put it into either one you can do. So y equals x squared plus 4x minus 12. So y equals -2 squared plus 4 times -2 minus 12. So y equals 4 minus 8 minus 12. So when I do the math, y is going to equal -16. So that tells me that the vertex is at -2 and -16. That's where the vertex lives. That's also why we didn't make our scale that goes up and down until now, because now we know that we have to incorporate this point here. So because we have to do that, well, my scale is going to go from -20 to 20. And if I have the point -2 and 16, it's going to live right here, I think. Is that right? 2, 4, 6, 8, 10, 12, 14. Yep. And then I can just take a pencil and draw a nice smooth curve. I don't know how smooth that is. I think I need to take my own advice a little bit more to heart. There we go. I like that better. That's a pretty nice smooth curve. There's our quadratic function, all right? So the key thing to do in this question in order to graph it is to factor it. Once we have it factored, we asked what made the blue and green highlighted areas equal to 0. We figured out it was 2 and -6. Those are our x-intercepts. Yes? What's that? What do you mean for -6? No, because this x equals -2 is halfway between these two values. Okay, it's halfway between these two values. So if this was a 5 and this was a 1, this would be a 3, okay? So the only thing that this has to do with these values is it's the halfway point between them. That's the key thing. You have to figure out where the halfway point is between these values, okay? And that's what we have to substitute into the equation. So halfway between 2 and -6 is -2. So we knew we had to plug in -2 into one of these two forms, and we did. And we found the y value that goes along with -2 is -16. So we know we have the point -2 and -16 on the parabola. Okay, makes sense? Awesome. Okay, now we're not done because the next thing does ask us to figure out the domain and range. So let's figure out that. Part B, what's the domain? What's the domain for this quadratic function? -infinity to infinity, correct. And that's awesome, okay? That's awesome. Yeah, no restrictions on the domain. How about the range? -16 to infinity. What brackets do we use? Beautiful, there it is. The range is -16, including -16, all the way to positive infinity. That is the range of that quadratic function. We good? All right, moving on to the next one. Use partial factoring to graph -x squared plus 4x plus 20. state, the domain, or range. So we have to talk about what partial factoring is, okay? So here's what partial factoring is. First off, I'm gonna make this bigger for me. Okay. Partial factoring means what we have to do is take a look at the first only, because basically what it boils down to is this. Basically what it boils down to is this. We can't factor this as it stands. There's not two numbers that multiply -20 and add to 4. There just aren't. The only numbers that multiply 20 are 1 and 20, 2 and 10, 4 and 5. They're not going to help you. So what this really is to help us do is, if we can't factor it, how can we still use, like, this is kind of a weird thing to say, but if we can't factor it, how can we still use factoring to figure out how to graph it? So we use partial factoring. That's how. So we take a look at the first two terms only. We take a look at the first two terms only, okay? And what we want to do is we want to factor these first two terms, and that's it. So if we want to factor those first two terms, what can we take out as a common factor from those first two terms? X. And you know what? Let's live dangerously. Let's take out negative x. We could take out positive x. We could take out negative x. I'm going to take out negative x. If I take out negative x, I'm left with x minus 4. And then I still have that plus 20 on the end. Okay? So I just took out negative x as a common factor from the first two terms. That's all I've done so far. So here's the thing. Now what we want to do is kind of the same thing we did before. Want to know what value of x makes this equal to 0, and what value of x makes this equal to 0. So we'll start with the green. What value of x makes this equal to 0? 0, okay. And what value of x makes the blue area equal to 0? 4. Now here's the difference with partial factoring and real factoring. Here's the difference. When we do the real factoring like we did last time, the full-blown factoring, what we were finding were the x-intercepts. We're not finding the x-intercepts this time. What we're doing is we're finding 2 points on the graph. And those 2 points have a y value of, those 2 points have a y value of 20. Because 20 is what's left over. So what we know here is we now have the points 0, 20 on the graph, and we have the points 4, 20 on the graph. All right? Now, it doesn't matter if we know zeros, or it doesn't matter if we know any other points. We know 2 points here. Is this parabola pointing up or down? Down. It's pointing down because the coefficient on the x squared is negative. So because the x squared is negative, here's what I know. I got the points 0, 20, 4, 20, and I know that somewhere in between those points, I'm going to have a point higher than that. How much higher than that? Well, I don't know that yet, but I can figure it out. Here's what I do know. My x values are 0 and 4. They're very nice numbers. So I know that my horizontal scale can probably go -10 to 10 as per usual. I know that for sure. I don't know what my vertical scale is, so I'm not even going to label those points yet. But here's what I do know, or should know, or want to know. Where's my axis of symmetry going to be? X equals what? 2. Because it's halfway between these two. Halfway between 0 and 4 is 2. So I don't know much yet, but I do know that my vertex is going to be somewhere along this red line. That's what I know. My vertex is going to be somewhere along that red line. So what I can do is, because it's at x equals 2, I can plug 2 into my function, and I can find out the y value. I can plug 2 into my function, and find out the y value. So y equals negative x squared plus 4x plus 20. I'm plugging 2 in, so that's negative 2 squared plus 4 times 2 plus 20. That's y equals negative 4 plus 8 plus 20. And it's negative 4 because it's not negative 2 we're squaring. The number we're squaring is 2. 2 squared is 4, and then there's a negative sign in front of it. Negative 2 squared would be positive 4, but that's not what this was. So when we simplify this, we get 24. Y equals 24. So the vertex is 2 and 24. So with that, we can make up our vertical scale. How do I want to do this? I don't know. Really doesn't matter. I'm gonna just go up to. I'm gonna go up to 4. I can't go up to 20 because that's not enough. I'm gonna go up to 40 because that's pretty much the best bet I've got. So I know I'm gonna label now. I gotta label 3 points. I gotta label 3 points here. I got. What's that? I like that idea. You know what? Okay. I'm easy. I'm easy. You want to go up to 30, negative 30? I got no problem with that. I got no problem with going up to 30. I was just thinking that 20 isn't divisible by 3. But you know what? We can live with that. We can go up to 30. I like that. We got to label 0, 20, and 420 on the graph. So 3, 6, 9, 12, 15, 18, 21. So it's going to be here. So like 0. So that's the 1 point. And then 4 and 20 would live like right here. So those were those 2 points. The 2 black points I've just drawn on the graph are the ones that we found right here. And we know that the vertex is going to be halfway between those points at x equals 2. So that's why we plugged in x equals 2 into this equation. And when we did that, we got 24. So 24 is going to live right up here. That's where 24 is going to live. Do we know what the x-intercepts here are? No, we don't. So we're just going to go ahead and graph this as best as we can. Okay. There's our quadratic, okay? Make sure to include those arrowheads because the graph does keep going on down, 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 down. Okay. Does it ask us anything about domain and range in this question? Yes, it does. So looking at the domain, what's the domain of this function? No. Domain. What's the domain of any quadratic function? Yes. Negative infinity to infinity for any quadratic function for the domain. What about the range? What's the range here? Negative infinity to 24. Got to put a square bracket on 24 because the function can assume the value of 24. That's the domain and range of this quadratic function. Okay, so that's the process of partial factoring. Partial factoring. Okay. All right. 2 more examples. Here's one. Find the quadratic function in standard form that matches the parabola given below. So what's this equation? What's this equation? Well, here's the thing. If we're talking about factored form, which is what we're doing today, the factored form, well, almost if we could figure out what the x-intercepts are, we can write the equation of a quadratic in this form here: y equals a times x minus r times x minus s, where r and s are the x-intercepts. And then we can use this equation as a template. We can use this equation as a template. This is a beautiful question, because all we have to do is substitute in the zeros and any additional point, and we can figure out the equation of this quadratic. So what are the zeros or x-intercepts of the parabola? 0 and 6, correct? So automatically, if it's 0 and 6, we're going to write y equals a bracket x minus 0, x minus 6. So we know that. We know that to be true. We know that to be true. And a is going to dictate two things. A is going to dictate which direction this parabola points. It's also going to dictate how skinny or fat the graph is. So to figure out the value of A, we have to identify one more point on this graph. One more point on this graph that we know is a point. So the problem is I could look at this point right here where my finger is. The problem is I know that the x value is positive 1, but I really don't know what that y value is. So I have to pick a point that I haven't chosen so far, so not the two x-intercepts. I have to pick any other point on the graph. And you know what? Well, maybe we could use these points down here. Actually, I think I will. What about this one right here? 2, 4. There we go. I like that point right there. X equals 2, y equals 4. So we're going to substitute in 2 for x and 4 for y and solve for a. So 4 for y, looking for a, 2 is x. All I did was substitute in 2 for x and 4 for y. And that's 2 times negative 4, which is like saying negative 8a equals 4. If I'm solving for a, I'm going to divide 4 by negative 8, which tells me that a is negative 1/2. A is negative 1/2. The negative part is obvious because the graph points down. If you don't get a negative for a and the graph's pointing down, that should be like a warning sign that something didn't go right. So the negative part is true because it's pointing down, and the value you can't really guess that. So right here in blue, we said this is what the equation is. Y equals a times x minus 0 times x minus 6. Now I can take my a value of negative 1/2 and plunk it in there. So that gives me y equals negative 1/2 x. I don't have to put x minus 0 because x minus 0 is just x, times x minus 6. This is in factored form, and that's the equation of the parabola that's graphed above. So a couple steps there. Locate the x-intercepts, plug them into that template I have written at the top that's highlighted.
To the school office, please. Mr. Katu, to the school office, please.
And then substitute any other point that you know is a point. The thing is if you guess on a value of x or y, it'll screw the whole thing up. So you have to pick a perfect point. And there might not be many of them on the graph, so you have to look carefully. You pick that perfect point, you solve for a, you plug that in, and there you go. Any questions on that? All right, I'm saving for the best for last here. The last question's a great one. The last question is a great one. It's a question that's asked time and time again in math. It's a maximum revenue question. Student council raises money by putting on movie nights in the gym. They usually charge $4 a ticket. At that price, they sell 48 tickets a night. From previous weekends, they know that for every 50-cent increase in price, 4 less people will attend. What should student council charge in order to maximize revenue? In these questions, you're given how many people are going to come out at the $4 price. That's like your basis. From there, we're told that if they increase the price by 50 cents, and that's true pretty much everywhere in the world. If you raise the price on something, less people are going to buy something. It's not always true, but it's mostly true. For every 50-cent increase, 4 less people will attend. So mathematically, what we want to find is how much should they charge per ticket to maximize the amount of money they're making. So this is a word problem. We have to develop the quadratic equation, and then we have to use the techniques we've learned today in order to solve it. So here's what I know. Here's what I know in pretty much every walk of life. If I'm trying to figure out the revenue, that's the total amount of money that's collected. In this case, it's going to be the ticket price times the number of tickets sold. Okay? The ticket price times the number of tickets sold. That's going to give me the revenue. So what I have to do is come up with an algebraic way of expressing that. Okay? Now, revenue, we can use the letter Y to represent. That's fine. That could be our Y. Now, how can we represent the ticket price? Well, we know that for the ticket price, the basis is the ticket price starts at $4. Okay? And so I'm going to put that there. And likewise, I'm going to put the attendance or number of tickets sold, however you want to label that. The attendance is 48 people. So as I change one of those, the other one changes at the same time. So for every 50-cent increase in price, so if I increase this by 50 cents, I know that 4 fewer people are going to attend. But here's what I also know. That I like if I do this once to 450, there's going to be how many people attending? 44 people attending. But I can keep doing it. So what if I do it to $5? How many people are attending? 40. So I'm going to take this 50 cents and I'm going to multiply it by the letter X, because X is going to represent the number of times I increase the price. And likewise then, the 4 will also be tied to X because it's going to be 48 minus 4 times the number of times we increase the price. So we do have to define our variables, or we should. So I'm just going to go, I don't know, anywhere you can. Y is the revenue, and X is the number of price increases. Okay? So Y is the revenue, and X is the number of price increases. So then we know that Y is equal to 4 plus 0.50 X times 48 minus 4X. And this is a factored form of this quadratic function. Now what we have to do is just like we've done for the other questions. If we find the zeros, then we'll be able to find where the vertex lives. And with a little bit more work, we can figure out what the vertex is. So we have to figure out what values of x make both of those brackets equal to 0. I'll start off with the easier one. What value of x makes 48 minus 4x equal to 0? No. What? What value of x makes this equal to 0? 12. So x equals 12 is one of the x-intercepts. Trickier question. What value of x makes that equal to 0? Now that's a tough one. So how can we do this? How can we figure this out? Well, we can actually write it out. And we could have written it out anytime we did this, yes? What's that? Hold that thought. If we set this equal to 0, we would write it like that. 4 plus 0.50x equals 0. We're going to do more of this tomorrow when we move on to the next lesson. But we have to solve for x. So if we solve for x, we're going to bring this over here. So it's going to be 0.50x equals negative 4 because it hops over the equal sign. So x is going to be negative 4 divided by 0.50, which is actually going to be negative 8, not 2. So it's negative 8. So I know that x equals negative 8 is also an x-intercept. In this question, we defined x to be the number of price increases. So if x is negative, what does that mean we're doing to the price? Huh? No. If x is the number of price increases, then if it's negative, we're doing what with the price? We're decreasing it. So in other words, if x is positive, we're increasing it. If x is negative, we're decreasing it. So here's what I know, and we don't know much so far, but here's what we know. And it doesn't say to graph this, but what I'm going to do is I am going to graph this. X can be negative in this situation. So I'm going to make a grid here. I'm going to make a grid, and I'm going to go like this. There's my x-axis. My y-axis is going to go something like this. Okay. And I don't know, like negative 8 is going to be like right about here. Yeah, negative 8 is going to be like right about here. 12 is going to be like right about here. All right. So what's the halfway point between those two, negative 8 and 12? What's the halfway point between negative 8 and 12? 2. 2 is halfway between those. So out comes my axis of symmetry here. And I'm going to label it because we don't have the luxury of a scale. And the thing is that revenue is going to be positive here. So I don't know where my vertex is going to live, but because I'm not really making a graph, like a fancy graph anyway, what I know is I can just draw it in like this and figure out what it is in a minute. I know that the revenue graph is going to look like this. Yeah, I could have done a better job of that, couldn't I have? Let's try a better job. Let's actually try to go through to the negative 8 this time. You know what? Good enough. Okay? Good enough. So here's what we know. Here's the interesting thing, actually. If we look at 12, what can you tell me about the revenue when x is equal to 12? 0. So in other words, if you raise the price 12 times, nobody's going to come out and watch the movie. Nobody. Not a soul. Okay? So you can't raise the price 12 times and maximize revenue. Well, you can, but you're not going to maximize revenue, that's for sure. And if you lower the price 8 times, if you think about that for a second, you lower the price 8 times, you're going to charge nothing. You're going to charge $0 to come to the show. If you're charging $0 to come to the show, you might have lots of people at the show, but guess what? Because you're charging $0, you're not making any money. Okay? So again, we're going to try and figure out what the question doesn't quite go there, but I'm going to answer it anyway. The question asks what ticket price should be charged to maximize revenue. In order to help you with your homework, we're going to find two things here. We're going to find the ticket price, which is asked, but we're also going to find out what the maximum revenue is. So the ticket price is tied very closely to x equals 2. Okay? Because that's the number of times you have to increase the price to maximize revenue. So going back up here, we said that the ticket price was 4 plus 0.50 times x. So if that's true, if the ticket price is 4 plus 0.50 times x, and x equals 2 maximizes the revenue because this is where the axis symmetry is, then I can plug 2 into this. And if I plug 2 into this, what ticket price maximizes the revenue? $5. So ticket price of $5 is going to maximize the revenue. Now, that's part 1 of the question. Part 2 of the question is, what's the maximum revenue? Well, up here, we defined y as revenue. So all we need to do is find the y coordinate of the vertex, whatever that is, and that's going to be the maximum revenue. So, okay. The equation we had was y equals 4 plus 0.50x, 48 minus 4x. And x equals 2 is the x coordinate of the vertex. So we know if we plug in 2, and we just did this work, so I'm not going to do it again. If we plug in 2 right here, we got $5. So I'm not going to do that math again. I know that this is $5 right here. But if I plug in 2 here, it's 48 minus 4 times 2. 4 times 2 is 8. 48 minus 8 is 40. So it's 5 times 40, which is a maximum revenue of $200. $200. Okay? One other thing. Because I told you we were going to look at 2 things. What price should we use to maximize revenue? $5. I told you I was going to do a second thing. Maximum revenue, $200. Yes? What's that? 5 times 20? No, 5 times 40 is 200. 5 times 20 is 100. Okay. This number right here tells us something different. This number right here tells us how many people are going to come see the movie. So when I have the 40, when I have the 5, and when I have the 200, they all tell me 3 different things. And we're gonna write this out all as one big sentence so that if you're doing a question for homework and it's only asking you for 1 or 2 things, you don't necessarily have to go the whole distance, but you're gonna be able to figure out everything. So, we talking about student council here? Yeah. So student council can reach max revenue of $200 by charging $5 to see the movie. Now, we didn't fix in the 40 people yet. We'll get there right now. And at that price, 40 students will buy tickets. So we have 3 things that we come out of this question with. The price that maximizes revenue, the maximum revenue, and the number of people that are going to buy tickets. Okay? Any questions about that? This is a cookie cutter question. I guarantee you're going to see this question again. I don't. It's like I don't know what your test looks like for this unit, but I know there's going to be a question probably like this on your test. So if you get good at this type of question, it's very beneficial to you. The other thing I know is that when I was doing your marks, we haven't really done a whole lot of. We've done like 2 quizzes and a test, and that's it. So we've got page 391 to 394, numbers 1 to 17 for homework here. And that is going to be your homework. That is going to be your homework. But what I'm going to do before the end of class is I am going to give you 1 or 2 questions, probably from that set, that I'm going to mark tomorrow. Okay? We'll talk more about that towards the end of class.